So how we can use shooting method to solve BVP? What is shooting method? Okay, so the shooting method for BVP, since shooting method, since BVP is you don't know all the initial conditions, then what is the shooting method? It's basically um, we will guess what can be the missing initial conditions. Then with the guessed missing initial conditions, we can solve BVP as IVP in the ODE um, program. So guess missing initial conditions to solve ODE BVP as ODE IVP with the guess initial value. Okay. And for our example that shooting a cannon to the shape, we don't know all the initial conditions, so we can guess what can be the initial conditions. Then until it meets the boundary values, we are done. So we have initial value. We know what is the z initial, that is the height of the mountain, but we don't know what is the Vx naught, Vz naught, because we don't know what is the angle we will shoot for the cannonball. So what we will have is V naught cosine theta for the Vx and V naught sine theta is for the Vz naught. That is basically we are guessing an angle for the cannon and we are trying to shoot the ball until it meets to the final conditions that the ball will be on the shape. Then we are done with this BVP. So we are guessing this initial. Then that leads to our second topics is what is the algorithm for the shooting method for the ODE BVP. Okay, so the algorithm for shooting method for, let's make a simple example, is a second order ODE with BVP problem. Okay. And we will tell step by step what is the algorithm in the programming, how we can solve BVP. Step one is as you have a second order BVP, you can translate that to two first order ODE. Okay, so second order ODE, what you can do is translate to two first order ODE. Okay, so for example, you have y double prime plus a y prime p y prime plus qy equals to some Boltzmann function. You can translate this y double prime to first ODE, which is you can write y1 equals to y prime. So y1 prime will be equals to y double prime, so that you can have two first order ODE. Okay. Then we have d over dx, y equals to d over dx, y1, y2, and that is fxy with boundary conditions y equals to y prime. So that is the boundary conditions. And you are translate this second order ODE into two first order ODE and write it as a state space format. Then we will trying to figure out what is the problem give us, what kind of boundary conditions we have. So we can write as a linear combination of the boundary conditions a1 y1 x plus b1 y1 prime x minus w1 equals to 0, a2 y2 x plus v2 y2 prime x minus w2 equals to 0. For example, if we have the only conditions is y1 and y2, then that means our b1 and b2, this term will be 0, okay? And y1 and y2 will be equals to w1 divided by a1, w2 equals to a2. And that is the value we are given from the boundary value conditions. Or you can have only the y1 prime, which is Newman boundary conditions, so that the a1, y1, a2, y2 term will be equals to 0. Then the y1 prime will be equals to w1 divided by b1. Y2 prime will be equals to w2 divided by b2. Or you can have the mix. Mix can be like y1, y2 prime, or y1 prime, y2, so that you can have those conditions. Let's first assume we only have the y1 and y2, okay? So assume the boundary conditions we have is Dirichlet boundary conditions, where the b1 y1 term and b2 y2 term will be equals to 0. So we assume that b1 equals p2 equals to 0, since we only have y1 and y2, right? The y1 x will be equals to w1 divided by a1, y2 x equals to w2 divided by a2. And this y1 and y2 equals to these values are given from the boundary value from the problem set. Okay, then what is the step 2? So step 1 is basically you are trying to understand this problem. What kind of boundary value conditions, what kind of state space matrices you can have. Then the step 2 is related to the shooting method. Is since you don't have all the initial values, you are trying to guess what can be the missing conditions. So guess the missing initial conditions. What is our missing initial conditions? We know y1, but we don't know what is y1 prime. So we can guess a missing conditions. We can guess that y1 prime equals to alpha, okay? So that y0 is our initial value. That will be equals to w1 over a1 alpha. And this can be solved by our ODE 23 or ODE 45 or whatever the options in the ODE program in MATLAB. And you are trying to solve this problem as an IVP by giving this initial guessing missing conditions, okay? And this part, we note that the alpha is to be determined, until the second boundary condition satisfied. So it doesn't mean this alpha will be your initial conditions forever. You have to guess this to solve the IVP and trying to get, okay, by solving this IVP with this initial missing conditions, what is our second boundary condition? And compare with whatever the problem set to give you and compare them, do the error analysis, trying to see, okay, we need to guess another alpha. We need to guess another alpha until this alpha meets the second boundary conditions is satisfied, okay? So the next step is that you probably the first guess is now satisfied for the boundary conditions. Then you make another guess. So give another guess, which is y1 prime. Instead of equals to alpha, you give another value beta. Okay, then your initial value become w1 over a1 beta, and solve IVP. okay, solve IVP. So between the step 2 and the step 3, basically you just give different initial gas conditions. Then you solve the IVP, then you will have 2 different solutions right now. So we are using these 2 different solutions to give us a better gas. We couldn't just, random guess for this immediate random numbers. We will give a better guess based on whatever we have in the past. So how to give a better guess? That is the step 4. We will do an arrow analysis. So from the step 2, you have solved the IVP with your initial guess alpha for the y1 prime, right? So this is the arrow 1. That is, you use your initial value, which is, you use the alpha. You solve what is you at y at x2 part. That is your boundary conditions, okay? And this is with the initial gas. Let's make it with the initial gas alpha and minus W2 over A2. So that is your boundary conditions you have from the beginning, from the problem side. You can have an arrow. Then the arrow 2 is similar. It's still at x2 point, but with the initial gas beta, you will have another arrow 2, okay? Then this arrow will be, the arrow will have a slope. The slope is as function of your gas, okay? So the delta arrow divided by delta, you can say the initial gas. Let's just use the initial gas, which is basically you alpha minus beta, right? So we can make it K there. That will be equals to arrow 2 minus arrow 1 divided by beta divided by alpha. So basically the arrow as function of your initial gas. Then you are trying to make the third gas will compensate your arrow, which is, so this is the second gas. The third gas, you are trying to compensate this arrow to be the negative part. So right now the arrow is go this way, then you want to go back. So the delta arrow for the third gas, you want to be exactly like this. So that the third gas can make our initial, our final solutions to go to the exact solutions. And that will be equals to the delta K prime times delta epsilon divided by delta K, okay? And that will be equals to whatever the second arrow, but opposite way. Then the delta K prime will be equals to negative epsilon 2 divided by d epsilon divided by dk, okay? Then your third gas, the next gas, will be equals to, so that is the y naught prime will be equals to beta, which is the second gas, plus delta K prime. So that the third gas is trying to compensate the arrow from the second gas, and that will lead to our exact solution. Now, we have, this is the algorithm for the BVP, and we will make an examples how to use this algorithm to solve the boundary value problem. Use an example, which is the second order, okay?